Hello, AP Physics. I know projectile motion can be a real sticky point when you get started, so I wanted to do an example problem here for projectile motion. And this one uses some different units than we've been using in class, but the concepts are the same that you apply. So if you notice here, we have feet per second instead of meters per second. That does change our value of G for this example, but not a big deal. Again, it's the same ideas. So I always start by drawing a picture of the situation. So I've got my initial velocity here, and it is 135 feet per second. And I have an angle of theta equals 25 degrees. And you're going to have to pardon my writing on my screen. It's not the greatest. So my first question asked me how long it takes to strike the ground. Well, ultimately what I'm going to have here is I have a situation where I'm taking off from the ground, I'm starting on the ground. And so this is going to be symmetrical. So if I can find the time to the top right there, all I have to do is double it. Okay, so let's ask ourselves, what do we know in this situation? Well, I know that I have some initial velocity, and part of that is going to be in the x direction. And part of that is going to be in the y direction. The other thing that I know is at the very peak, the y velocity becomes 0 because that's when the projectile starts to fall down. And the last thing that I know is I know my acceleration due to gravity, and that's a constant. And for feet per second squared, that is 32 feet per second squared. Again, on the AP Physics exam, you'll always use 9.8, but it's the same concepts. So if I plug in my values for the initial velocity and my theta values, I find that my initial x velocity is 122 feet per second squared, or feet per second. And my initial y velocity is 57.1 feet per second. Okay? Okay, so now let's start looking at the situation. I can use the equation that my final y velocity is equal to my initial y velocity minus g times t, and I'm doing the minus because gravity is going in the opposite direction of the initial velocity. So if I plug this in, 57.1 feet per second minus 32 feet per second squared times t, and I solve for t, I find that my t to the top is 1.78 seconds. So to get the total time of flight, I just have to double that. So t total is equal to 2 times 1.78 seconds, which is 3.56 seconds. Okay, so that's our time of flight, which isn't bad. And if we look then at part B, we want to know how high is it going to go. So let's look at part B now. So this is part B. Now I want to know height. So I want to know my max height. Okay. I still know the things that I knew before. I know the initial y velocity. I also know that my initial height is 0 because I start from the ground. I still know gravity, and I know the time that it takes to get to my maximum height. So that time to the maximum height we found in the last part is 1.78 seconds. So I can choose this equation right here. Now often I get asked, how do you know what equation to pick? Well, see how I keep writing out all of my givens and my unknowns, things I want to find, and I'm writing out the actual variables, and then I write the values if I know them. That helps me look through the equations and see, okay, what's a good match? If I have one unknown, then I have one equation I need to use. If I have two unknowns, then I have two equations I need to use. And I can see what can I fill in. So right now, we're gonna try and find our y max is equal to 0 plus our initial y velocity of 57.1 meters per second times our time of 1.78 seconds minus 1/2 times g, 32 feet per second squared, running out of room, times 1.78 seconds, and make sure you square that. Scroll down, solve. Y max is then equal to 50.9 feet. Okay? And the last part asks for the range. Okay, so that's the horizontal range. I'm going to show you two different ways that you can solve this. There is a range equation that exists, and this range equation is valid only if the initial and final altitudes are the same. So the fact that this took off from the ground and landed at the ground makes those level, and so they're the same, so this is a valid equation to use. The other equation you can use is to find your horizontal distance x is going to equal your horizontal velocity times the time of flight. So this range equation is a good one if you don't know the time of flight, and then the other one works if you have the time of flight. They get roughly the same answer within rounding. In this case, it's just a little bit off because I rounded the time and whatnot. So, plug in my range, and I take my initial velocity, and it's the overall initial velocity that you use. Square it, sine of 2 times 25 degrees, divided by 32 feet per second squared, and the range for this problem is 436 feet. If you plug into this one, you get 434 feet. So like I said, it's within rounding. Any questions, let me know. Otherwise, I hope that was useful.